Alright, the first problem on the study guide, we got negative 9x plus 5y plus 7y plus 10x. We're supposed to simplify. All we're doing here is looking for like terms. We're going to underline the like terms. Negative 9x and 10x are like terms. Positive 5y and positive 7y are like terms. We make a decision to add or subtract based on signs. If the signs match, we add. If the signs are different, we subtract. So the x's, negative 9 is different than positive 10, so we subtract to get 1x. 10 is bigger than 9, so it's positive. Positive 5y and positive 7y are both positive, so we add to get 12y. 7 is bigger, so it's positive. That is the correct answer. If you want to write x instead of 1x, that's fine. Doesn't matter one way or the other, they mean the same thing. Number 2, we're going to multiply 7x times the binomial negative 6x plus 4. This is the distributive property. The outside object, which is 7 and x positive, is going to be multiplied through the parentheses. So we're going to multiply by negative 6x, we're going to multiply by positive 4. Positive 7x times negative 6x, different signs create a negative product of 42. The x and x make x squared. We add the powers. It's x the first, x the first. We multiply positive 7x times positive 4. Positive times positive makes a positive. 7 times 4 is 28, and then x times nothing else just stays x. And that's the entire answer there. Number 3, two distributive properties happening here. This is a positive 2x being multiplied through this parentheses. This is negative 6 being multiplied by through by this parentheses. Make sure the sign's included in your work there. So when you're multiplying, make sure you're considering the sign. So positive 2x times positive 3x makes positive 6x squared because the signs are the same. 2 times 3 is 6, x and x make x squared. Positive 2x times negative 4 makes negative 8x. Because the signs are different, we get a negative answer. As we distribute, the parentheses disappear. So 2x times both of those creates these two. That one's done. Negative 6 times positive 5x is negative 30x. The signs are different. That's why I multiply and get a negative. And negative 6 times positive 4 makes negative 24. Once again, different signs creates a negative product. Once again, the distributive property happens, the parentheses disappear. What's left to do then is to look for like terms. 6x squared, 8x, 30x, 24. These two both have x to the first power, they're like terms. So just like problem number 1 now, we're adding like terms. These are both negative, so I'm going to add to get 38x. 30 is bigger, so it's negative 38x. 6x squared has no like term, and negative 24 has no like term. Nothing happens to them. That is the final solution to that. Number 4, we're multiplying a binomial structure times a binomial structure. Notice there's no plus or minus between, which means multiplication. The technique I showed you for this is FOIL. So we're going to do first times first. That's the F part of FOIL. Negative 4x times positive 2x makes negative 8x squared. Outer times outer. Negative 4x times positive 5 makes negative 20x. Inner times inner. Negative 3 times positive 2x makes negative 6x. Last times last. Negative 3 times positive 5 makes negative 15. In every case I multiplied. When I multiplied I was thinking of signs. Negative times positive makes a negative. In every case that's what we had. Negative times positive, negative times positive, negative times positive, negative times positive. Once again, once we multiply everything together, we look for like terms. X to the first, x to the first. These are like terms. X squared and constant have no like terms. So nothing happens to negative 8x squared. These are both negative, so I add to get 26x. When the signs match, I add. The bigger number is negative, so it's negative 26x. Minus 15 has no like term. Nothing happens to it. That's the best we can do. Number 5, we're multiplying a binomial times a trinomial, and the technique I demonstrated for this is the advanced distributive property. So we take the first object, 5x, we're going to multiply by the entire second object. So it'll be 5x multiplied times 3x squared plus 2x minus 4. Then we take the second object in the first parentheses, negative 2, multiplied by the entire second parentheses. So minus 2 times 3x squared plus 2x minus 4. Simply notice here that 5x is here, negative 2 is here, and we're simply multiplying both those initial objects times the second parentheses. There's 3x squared plus 2x minus 4. 3x squared plus 2x minus 4. Again, that's all that's happening. First object times the entire second parentheses, second object. That says minus 2, so that says minus 2. Now we simply distribute, very much like problem number 3 was. We got something times something, something times something, so we're going to do it the same way. So we've got 5x times all three things here. Again, when I'm multiplying, I'm thinking of signs. Positive 5x times positive 3x squared makes positive 15x to the third power. 1 plus 2 is 3 for the powers. Positive 5x the first times positive 2x makes positive 10x squared. Positive 5x times negative 4 makes negative 20x. Now I'm going to take negative 2 times each thing in here. Negative 2 times positive 3x squared makes negative 6x squared. Opposite signs makes a negative. Negative 2 times positive 2x makes negative 4x. Negative 2 times negative 4 makes positive 8. In every case, I multiply. The signs matter as I'm multiplying. Same signs get me a positive, different signs get me a negative. Same signs got me a positive, different signs got me a negative. Once I do all the multiplications, again, the distributive property makes the parentheses go away. Like term, like term, like term, like term. Look for like terms. Same letters, same powers. X cubed is the only x cubed. X squared matches. X matches. 8 doesn't match with anything. So nothing happens to 15x cubed. Positive 10x squared, negative 6x squared. These signs are different, so I subtract to get 4x squared. 10 is bigger than 6, so we're going to go positive because 10 is positive. Negative 20x, negative 4x, the signs match, so I add to get 24x. 20 is bigger than 4, so negative, and then plus 8. Notice when I'm multiplying, x times x squared makes x cubed, x times x makes x squared. The powers are changing. When I add and subtract, these signs were different. I subtracted, the power stays the same. X squared, x squared, x squared, x, x, x. So be careful to make a distinction between multiplication of letters and addition or subtraction of letters. So that's all the simplifying stuff on the test. Number 6, we're going to solve just a basic two-variable, two-number equation. X and number on one side, x and number on the other side. I'm going to take my 3x, which is on the right, and move it to the left. So everything x is on the left. I'm going to take the negative 9, move it to the right. In both cases, whatever I move is going to change signs. The 3x is positive, becomes negative when I move it. The negative 9 is negative, becomes positive when I move it. When I go across the equal sign, that happens. 7x minus 3x makes 4x on the left. 10 plus 9 makes 19 on the right. Divide by 4, whatever's in front of x is what we divide by. So x equals 19 fourths. As always, if it doesn't reduce, leave it as a fraction. So 19 fourths would be the answer to that one. Number 7, a little bit more complicated solve. We have the distributive property on the left and right, so very much like we were doing a moment ago. We're going to distribute, we're going to do 3 times this and 3 times this. So 3 times positive 5x is positive 15x. The signs match, so I get a positive. Positive 3 times negative 3 makes negative 9. The signs are different, so I get a negative. Then the equal sign happens, so that side's finished. And on the right side, I've got negative 2 outside being multiplied through this parentheses. And again, the negative is attached to the 2. Negative 2 times positive 4x makes negative 8x. Negative 2 times negative 9 makes positive 18. When I distribute, the parentheses disappear. So I multiply the 3 through, the parentheses disappeared. Multiply the negative 2 through, the parentheses disappeared. Now I'm in the same place the last problem was. I got x number. I want x on the left, so I'm going to take the negative 8x, move across the equal sign, becomes positive 8x. Take the negative 9, move across the equal sign, becomes positive 9. These are the same signs, so I add, I get 23x. 15 is bigger, so it's positive. These are the same signs, so I add 27. 18 is bigger, so it's positive. 23x equals 27. We simply divide by 23 on both sides because x has a 23 in front of it. And that doesn't simplify, so 27 over 23 is the correct answer. If it reduced, you should reduce it. If it ends up being a whole number, you should do that. But 27 23 doesn't reduce. Number 8. Here's very much like the last problem, 3 times the distributive property, times a parentheses distributive property. This minus 6 is not in the parentheses, so nothing happens to it. So if I'm fixing this bit here, just this bit with the distributive property, Positive 3 times positive 4x, same sign makes positive 12x. Positive 3 times positive 5, same sign makes positive 15. Minus 6 is just hanging out. We don't do anything with negative 6 yet. On the right-hand side, nothing's happened with negative 8, or the 8, just the minus 7 here is being multiplied through here. So again, I've got a distributive property look. I want to fix that before I worry about the 8. So nothing's happening to 8, just leave it alone. Negative 7 times negative 6x makes positive 42x. Same sign, positive. Negative 7 times negative 5 makes positive 35. Same sign makes a positive. Okay, once I've done that, the distributive property got rid of all the parentheses. Now I look on the left-hand side, which is all this stuff. I look for like terms, 15 and negative 6. And on the right-hand side separately, I look for like terms, 8 and 35. All four numbers are regular numbers, but 2 are on the left, they interact with each other. 2 are on the right, they interact with each other. So they don't work together right now. We've just got separate things here. So 12x has no like terms. 15 minus 6, the signs are different, so I subtract. 15 is bigger, so it's positive. 42x, nothing's happening to it, so I write it down. 8 plus 35, they're both positive, so I add. 35 is bigger, so it's positive. And again, my problem gets down to this point where I have x number. Every one of these equations gets down to this level. I'm going to move my x to the left, so minus 42x comes over here. Move my 9 to the right, so minus 9 goes over there. 12x minus 42x, these signs are different, so I subtract to get 30x. 42 is bigger, so it's negative. These signs are different, so I subtract to get 34. 43 is bigger, so it's positive. What's left to do is whatever's in front of x to divide by, so divide by negative 30. Divide by negative 30. And again, we should reduce, if possible, both 34 and 30 are even numbers, so they divide by 2. So I'm going to get x equals 17/15. And the fact that there's one minus sign in the whole fraction here makes it a negative fraction. The minus sign can go anywhere. I prefer to put it on top, but as long as it's just one negative in the whole fraction, you're right. So negative 17/15 is the right answer to that one. All right, for number 9, we're going to simplify this. The first thing that we're going to focus on in a simplification using the laws of exponents is this structure here, where we have parentheses to a power. Anything not looking like that, nothing's going to happen to it. So to start off with, my first step, I'm going to rewrite 3x to the 0 because nothing happens to it. What's in this, I have a 2 to the second power, so 2 is the base, and I'm going to multiply power inside times power outside. Keeping in mind multiplication is the same rules as always been. A positive 2 times a negative 3 makes a negative 6. I got a base of x, I'm going to multiply the inside power times the outside power. Negative 6 times negative 3 makes positive 18. My base is y, inside power times outside power. Positive 3 times negative 3 makes negative 9. Bottom, same deal. I've got 2. All right, if you have just a number, this is a number to a power, the power is multiplied. This is just a number in a parentheses raised to a power. So this number is being raised to that power. So times 2 to the negative 4th. For me, if I got times a letter, I just write the letters. But if I got times a number, I put a multiplication symbol in front of it. I got a base of x. I'm going to multiply power times power. Negative 5 times negative 4 makes positive 20. And then y is my base. I take my inside power times outside. 2 times negative 4 is negative 8. So that's what step 1 is. And just like the distributive property, when I do this process, the parentheses disappear. So this has parentheses. Make the parentheses disappear legally. That's always job 1. The next thing I look for is negative powers. Anything negative power needs to be fixed. Also 0 power. So this and this and this and this are all in the wrong place. And x to the 0 power, I can just strike out any 0 power. It equals 1 times 1 doesn't do anything. Everything that's not circle is going to stay right where it's at. So I'm going to keep x to the 18th on top. I'm going to keep x to the 20th on the bottom. I'm going to keep 3 on the bottom. And then everything that's circled is going to move to the other part of the fraction. So things on top to negative powers move to the bottom. I like to put all the numbers in front, so I'm going to do times 2 to the 6th. I'm going to do a y to the 9th. So this times this times this times this. I'm moving the 2 to the 4th up, and I'm moving the y to the 8th up. this times this times this. I always put the numbers in front. When you move them where they belong, the powers become positive. Negative 4 on the bottom, positive 4 on top. Negative 6 on top, positive 6 on the bottom. Negative 9 top, positive 9 bottom. Negative 8 bottom, positive 8 top. Next step is to fix the top completely, the bottom completely. That involves evaluating powers, multiplying numbers, and if you have the same letter happening, fix that. Okay. On top, the only issue, I can evaluate 2 to the 4th power. On the bottom, the only issue, I can multiply 3 times 2 to the 6th power. I only have one x and one y and one x and one y, so everything letter-wise is fine for that. So if I go ahead and evaluate those, 2 times 2 is 4, times 2 is 8, times 2 is 16. X to the 18th power is going to stay the same, y to the 8th power is going to stay the same. On the bottom, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 64 is being multiplied by 3. Notice 2 is to the 6th, 3 is actually to the 1st. So 64 times 3 is 192. And then we have x to the 20th power, and we have y to the 9th power. Final job now is to reduce the fraction by dealing with multiple letters of the same type and by reducing the fraction if possible. Now, 16 and 192, obviously both even. If you notice, 2 to the 4th power, which is 16, and this has 2 to the 4th power also, I can kind of look back here to kind of get an idea of if things reduce. So the fact that 16 is in this one and 2 to the 4th, 16 is in that one, tells me both those numbers divide by 16. So the top becomes 1, and if I do 16 into 192, I get 12. All right. X belongs wherever the higher power is. This is the higher power of x, so x belongs in the bottom. I take the big minus the small power. 20 minus 18 is 2. Y belongs wherever the highest power of y is, which is the bottom, so y belongs in the bottom. Big minus small, 9 minus 8 is 1. You can write a first power, you don't have to. I usually don't. 1 is necessary when nothing else is there. So if, for example, if y ended up on top, if I didn't have the 1, it's fine. But since nothing but 1 showed up on top, that 1 is necessary for that problem. So 1 over 12x squared y would be the simplest form of that expression. Number 10, we have a system of equations. My first task is to get x, y number order. So notice we have 4x plus 40. That means 40 needs to move over there. Equals 3y and needs to move over there. So if I rearrange it, 4x is right where it belongs, stays positive. 3y moves to the left, becomes negative 3y. 40 moves to the right, becomes positive 40. Then the bottom equation says 2x plus 5y equals 6. That's in perfect order. So 2x plus 5y equals 6. Next task is to decide, I'm going to get rid of x, I'm going to get rid of y. It's your choice, doesn't matter. I'm going to choose to get rid of y. I like opposite signs, so I don't have to deal with any multiplication by negatives. So I want to make 3 and 5 into the same number through multiplication. That number is going to be 15. 5 times 3 makes 15. 3 times 5 makes 15. This product here is going to be negative 15y. That's going to be positive 15y. I'm looking for those opposites. Okay, what's in blue with the blue arrows is what I want to happen. The consequence of my actions is 5 is going to multiply by 4x and 5 is going to multiply by 40. 3 is going to multiply by 2x and 3 is going to multiply by 6. Fix what you want to fix, but everything else has to be modified also. So the top equation, multiplying everything by 5, positive 5 times positive 4x makes positive 20x. Positive 5 times negative 3y makes negative 15y. Positive 5 times positive 40 makes positive 200. On the bottom, positive 3 times 2x makes positive 6x, same sign positive. Positive 3 times positive 5y makes positive 15y. And positive 3 times positive 6 makes positive 18. Now that I've got opposite y's, now I'm going to add the two equations together. And I'm going to get 20 plus 6 is going to be 26x. The signs are the same, so I added. 20 is bigger, so it's positive. Negative and positive 15y cancel. And 200 plus 18 is 218. Divide both sides by 26. And let's see, 218 divided by 26 reduces to 109 over 13. And I don't believe that divides evenly. So if I grab a calculator for that. 109 divided by 13 is a decimal. So 13 is a prime number, that doesn't reduce anymore. So x equals 109/13. All right, since x came out as a fraction, I'm going to go back and eliminate x to find y. So we eliminate y, we found x equals. So now if I eliminate x, I can find y. So I go back to my original problem, 4x minus 3y equals 40. Ooh, I just realized what I did wrong. That should be negative 40. There's a good example of how to do the problem wrong. So 40 moved to the right should have been negative 40, which makes this negative 200. This is still 26x, but now this equals negative 182. So now if I divide by 26, let's see if that's friendlier. So negative 182 divided by 26 is negative 7. Perfect. All right, so once again, 40 moved right should have been negative 40. Negative 40 times 5 makes negative 200. Negative 218, different signs subtract, you get 182, but negative because 200 is bigger. Divide both sides by 26, we get negative 7. Once we know what x equals, and it's a friendly integer answer, the best way to go back to find the other answer is just replace x either here or here with your answer. So I'm going to go to this bottom one. It says 2x plus 5y equals 6. X equals negative 7. So instead of writing 2x, I wrote 2 times negative 7. 2 times negative 7 is negative 14, different signs negative, plus 5y equals 6. 14, chop it off this side, move it to this side, becomes positive 14, so 5y equals 6 plus 14 is 20. Same sign, add 14, bigger positive. Divide by 5, y is equal to 4. So my correct answer is negative 7 for x, 4 for y. I'll try to do 11 with no mistakes. So, number 11. The top equation is exactly as it should be. Something x, something y equals number. The bottom equation, x is over here, number's over there. So 5x has to go left, 10 has to go right. So since I have to change one of them, I'm going to go ahead and rewrite both of them. So x plus 3y equals 9. The second equation, 5x is moving all the way over here, so negative 5x. Positive becomes negative as you move left. Plus 7y, 7y is positive, stays positive, equals 10 moves right, becomes negative 10. Once again, I got to get rid of something, either x or y. I like the opposite signs on x's. And also, all I have to do is take the top by 5. 5 times x makes 5x, opposite of negative 5x. So I'm going to multiply the top equation times 5. That's going to get me 5 times x. What I want is positive 5x. The consequence is I get 5 times 3y, which is plus 15y. And 5 times 9, which is equals positive 45. Positive times positive makes positive. Positive times positive makes positive. Positive times positive makes positive. This is now my system of equations. I'm going to add together. Negative and positive 5x cancel. 7y plus 15y makes 22y. Same sign, add, 15 is bigger, positive. These are different signs, subtract. 45 is bigger, so it's positive. Divide both sides by 22. We get y equaling a fraction, 35/22. So again, as I was going to say on the other problem when I had the wrong answer, this is the right answer, 35/22. So when I get a fraction answer, the best plan is to go back to the original problem, which is x plus 3y equals 9, and negative 5x plus 7y equals negative 10. Go back right where we were to start off with. And now I'm going to eliminate y. I want the y's to be opposites of one another. When I eliminated x, I found y. If I eliminate y, I'll find x. I can make both 3 and 7 become the number 21. So I'm going to take the top equation times a positive 7. The bottom equation and multiply by negative 3. Doesn't matter which one's negative, just make one of them negative. So 7 times 3y, this makes a positive 21y. Negative 3 times 7y makes a negative 21y. And then 7 gets multiplied by x, and 9 is a consequence. Negative 3 gets multiplied by negative 5x, and negative 10 is a consequence. So when I do all my multiplications, positive 7 times positive x makes positive 7x. Positive 7 times positive 3y makes positive 21y. Positive 7 times positive 9 makes positive 63. Negative 3 times negative 5x makes positive 15x. Signs are the same, so you get a positive. Negative 3 times positive 7y makes negative 21y. The signs are different, you get a negative. And negative 3 times negative 10 makes positive 30. Signs are the same, so you get a positive. I've successfully gotten the y's to be opposite. One's positive 21y, one's negative 21y. So now I'm going to add the equations. 7x plus 15x, both positive, add to get 22x. Positive because 15 is bigger. 63 and 30 are both positive, add to get 93. 63 is bigger, so it's positive. Divide both sides by 22. So x equals 93 over 22. Even though we found y first and x second, we write our ordered pair with x in front. So x goes first, 93 20-seconds. Y goes second, 35 20-seconds. Again, always write your answer for these as an ordered pair, x first, y second.